Welcome to my channel Learn, Grow and Rise. Hope all are fine and doing well. Let us continue our discussion on acid, base and salt, and today we will discuss one important topic of this acid base salt, that is indicator. And in indicator we will discuss introduction, definition, types of indicators, natural indicators, synthetic indicators, olfactory indicators, universal indicators, pH scale, importance of pH, and lastly we will discuss few important questions to do excel in your exam, that is in our exam decode session. So let's start. What is indicator? Before that, let us give one example. There are two solutions, solution A and solution B. Your teacher told you one solution is acidic and another solution is basic. So please bring acidic solution for me. But when you saw both the liquids are same in color, so how can you know that which solution is acidic and which solution is a basic? Yes, children, there is a simple technique you can use. You can test the test. You can test the solution, and when it tests sour in nature, so if it is sour taste, then you will say, ma'am, it is acidic. But when it tastes bitter, so you can say that, ma'am, it is base. But all the chemicals are not safe. We cannot know whether it is acid or base by using the test technique. What can we do then? We can use this test to know that whether the solution is acidic or basic. To do this test, so what can we do? We can use another substance that is called indicator. So let's know what is indicator. Indicators are the substance which indicates the change in characteristic properties like color, odor, etc. of a substance which change in the medium like acidic medium and the basic medium. So what is indicator, children? Indicators indicates. What it indicates? It indicates the change in color or odor when it comes in contact with the acidic or basic medium. Such substances are also known as the acid-base indicator. Why, children? Because they are indicating the medium or the presence of the substance, whether it is acidic or basic. That's why these are known as the acid-base indicator. These indicators show different color in the acidic medium and basic medium. Now, let us know how many types of indicators are there. There are 4 types of indicators: natural indicators, synthetic indicators, olfactory indicators, universal indicators. Natural indicators, synthetic indicator, olfactory indicators are known as acid-base indicator because it gives the idea whether the substance is acid or base. But universal indicator will tell us whether the substance is acid or base, as well as it will give the idea about what type of acid it is, whether it is a strong acid or weak acid, whether it is a strong base or weak base. Now, let us discuss one by one each indicator with examples. Natural indicators. Natural indicators, as the name suggests, children, natural means definitely we are getting this indicator in nature. These are the natural substances that indicates the presence of acidic or basic substance by changing its color. For example, litmus, turmeric, red cabbage, China rose, grape juice, etc. These are the indicators which indicates change in their color, and these are obtained in nature. For example, litmus. Litmus is a substance that is obtained from a plant called lichen. Lichen is a plant, and lichen is a favorite food of the reindeer, children. So this lichen shows 2 types of flower. One is a red flower and another is a blue flower. From the red flower we are getting, or we can prepare the red litmus, and from the blue flower we can prepare the blue litmus. So there are only 2 litmus, red and blue. No other color litmus you will get. So So the red color indicates whether the solution is acidic, if the solution is acidic in nature, and the blue color indicates if the solution is basic in nature. So now let us check it. So when we bring the red color litmus in contact with the acidic solution, there is no change in color. But surprisingly, if you bring the blue litmus in contact with the acidic substance, it turns to red in color. So the blue litmus turns red. So blue changes to red here, but red no change. Now, let us discuss about the blue litmus. When we bring the blue litmus in contact with the basic solution, there is no change. But when we bring this blue litmus in contact with your acidic solution, it will turn to red. So, blue litmus, blue, no change. But red litmus, if you will bring, that will turns to blue. Okay, so children, I am just giving a basic trick to remember, children. B stands for basic, so blue always remains with base. Children, you remember, whatever you bring to contact, which type of litmus you will bring in contact with the base, it turns it to blue. Because base loves B. Base loves blue color. Okay. So if you remember one, other you can write easily. So this is the trick to remember, children. Now another indicator, natural indicator, is turmeric. Turmeric is a very common ingredient in our kitchen. You can do this test by taking the turmeric at your home also. If you bring the turmeric solution in presence of the acidic solution, there is no change in color. But if you bring this turmeric with the in contact with the basic solution, it turns to red brown. Red cabbage. If you bring the red cabbage solution in contact with this acidic, the color turns to red or reddish pink in color. But when you bring it in contact with the basic solution, it will turn to green. Flower of hydrangea. Hydrangea flower, when you brings in contact with the acidic solution, it turns blue, and when we bring this is in contact with the basic solution, it will turn pink in color. So this is all about your natural indicator. Now let us discuss about the synthetic indicators. As the name suggests, synthetic indicators are the chemical substances that prepared in the laboratory or synthesized in the laboratory, and it indicates the presence of the acid and base by changing its color. Two types of synthetic indicators are in your syllabus. So one is a methyl orange, and the color of this indicator is orange in color. When we bring this methyl orange in contact with the acidic solution, that turns orange to red, and when we bring this orange color in contact with the basic solution, it turns to orange to yellow. Now phenolphthalein. Phenolphthalein is a colorless indicator. When we bring this indicator in contact with the acidic solution, no change in color. But when we bring this phenolphthalein in contact with the basic solution, immediately it turns to pink color. So this is all about your synthetic indicator. Now let us discuss about the olfactory indicator. Olfactory indicator is a substance whose smell varies depending on whether it mixed with the acidic or basic solution. Children, you know olfactory word is associated with the smell. Olfactory nerve. Olfactory nerve is the nerve which is associated with the smell. So, the olfactory indicator is a substance whose smell varies depending whether it is mixed with acidic or basic solution. For example, onion. If onion you will bring in contact with the acidic solution, that retains its smell. But when we bring this onion in contact with the base or alkaline solution, you will get it loses its smell. Like this, the vanilla. Vanilla we are using in the cake. That vanilla essence, if you will bring in contact with the acidic medium, it retains its smell. But when you bring in contact with the basic medium, it loses its smell. Now, the most important indicator is your universal indicator. Universal indicator is an indicator which not only tell us whether the substance given to us is an acid or base, but it will emphasize whether what is the strength of this particular solution, whether it is a strong acid or strong base or weak acid or weak base. So let us know what is universal indicator. Universal indicators are the mixture of organic dyes. It prepared when we mix various dyes. It is a mixture of the organic dyes. These indicators indicate the chemical nature, whether acidic or basic of the substance, as well as the strength of the substance in terms of the pH. And what are the common example of the universal indicator? It is pH paper, universal indicator solution. Both this you can get easily in your laboratory. What is pH? What is pH scale? pH scale is used to measure the hydrogen ion concentration. So, what is hydrogen ion concentration, children? Children, you know, when we dissolve an acid in aqueous solution, it produces is hydrogen ion, and that hydrogen ion react with the water to produce the hydronium ion. So, how much hydronium ion or hydrogen ion that acid produce when it dissolves in its aqueous solution is known as the hydrogen ion concentration. So, pH will tell measure the hydrogen ion concentration. The P in the pH stands for potence, and which means power in German, and H in pH stands for hydrogen ion concentration. It has a value ranging from 0 to 14. It is a scale. You know, in the scale is graduated with a certain number, like your meter scale 0 to 100. Like this, the pH scale is graduated with a number that is 0 to 14, and 0 to 7 is the acidic, 7 is a neutral pH for the neutral solution, and 7 to 14 is the pH for the alkaline solution. Higher the hydronium ion concentration, lower the pH. The more the hydronium ion concentration is, the pH value reduces, because the pH is the formula. What is the formula for the pH? pH is equal to minus log base 10 H plus ion concentration. So, more the H plus ion, more the negative value, and less the pH value. So, pH is a number that indicates acidic or basic nature of the solution. pH value changes with change in temperature. pH value used to compare relative strength of the acidic solution or basic solution. Children, when we increase the temperature, what happened? The acid dissociated, or the acid dissociated very fast and produce more amount of hydrogen ion. More amount of hydrogen ion, if it will produce on heating, when we change the temperature, the amount of hydrogen ion is more. When the amount or the concentration is more, as the pH value depend on the concentration of the hydrogen ion, so it will change the value of the pH. Okay, so now pH value used to compare relative strength of the acidic solution or basic solution. If the pH value is less than 7, then the solution is acidic in nature. So when we move from 6 to or 7 to 0 in the pH scale, the acidic character increases gradually. And when we move from 7 to 14, the basic character or alkaline character increases. So if the pH value is equal to 7, the solution is neutral in nature, and if the pH value is greater than 7, the solution is alkaline in nature. It is a color change by universal indicator. pH is always have a range. You will not get the number continuously in the pH scale. You cannot get 0, then 1, then 2, then 3. After 1, you may get the number 3, because pH always shows you a range of the value. Okay, a range, so that in that range particular color is coming, and in that color you can say what is the nature of the solution. pH value and range. If the value is 0 to 3.5, the color of the solution is red. If the value is then if the value is 0.3.5, then the pH paper or the universal indicator color solution turns to red and it indicates it is a strong acid. If it is 3.5 to 5.5, then it is orange and the nature is acidic. If it is 5.5 to 6, it is yellow and it is weak acid. If it is 7, then color shows green and it is neutral in nature. If it is 7.1 to 10.8, it is blue in color. Nature of the solution is weak alkali. If it is 10.8 to 12.6, then color of the solution is indigo and nature of the solution is alkali. And it is 12.6 to 14, it is violet and it indicates presence of a strong alkali. You can see here the pH of pH of few substances or different substances that is we are using in day-to-day life. You can see the lemon juice, the pH is 2 and it is acidic in nature. The orange juice, tomato juice, black coffee also acidic in nature, having the pH is 5, slightly acidic. You can see the milk of magnesia we are using when we have the gastric problem, when we have the acidity. Acidity when almost all of us have experienced the acidity. To neutralize the acid, we can use the basic solution and it is the milk of magnesia. So here the chart you can see and you can get a knowledge about various substances we are using and what is its pH and whether the solution is a strong acid or strong base or weak acid or weak base. Now let us discuss the importance of pH in our daily life. pH of the plants and animals are fixed, or the plants or animals are pH sensitive. Before that, I have given one example of litmus. I have given the example of hydrangea flower. So when we bring this litmus plant to the wheat soil, if it is grown in an acidic soil, it gives you red flower. So litmus in acidic soil gives red flower, and red flower in acidic soil and blue flower in basic soil. Okay. Now the pH level is important because you know that there are many crops which grow in the alkaline soil. There are many crops which love to grow in the acidic soil. It is important to maintain the pH of our digestive system. If there is a change in the pH, there is a problem in the digestion because the digestion is caused due to the presence of various type of enzyme and all the enzyme works in a definite pH. If there is a change in the pH, the enzyme will not work and there is a problem in our digestion. Now, pH changes the causes of the toothache. If the pH changes, because you know that tooth decay is due to the acidic. One acid is present and acid helps to decay in the tooth. That's why it is advised you people to brush your teeth before you go to the bed. So if we brush your teeth and we know that our toothpaste contain base, so we are changing the medium to the alkali and we save our teeth from decaying. Now, the self-defense by animals and plants through the chemical welfare. Okay, so we know that there are many plants and animals, they also have a self-defense mechanism like your honeybee, like your wasps. So they contain the formic acid and it contain a mild acid. Okay, so they also maintain a constant pH in that when they are stinging, they are injecting that acid in our body and just to protect themselves. Okay, so these are the importance of the pH in our day-to-day life. Now, all of you ready for the most important part, that is our exam decode session. So let us solve few questions. The question is that you can see one table here. In the table, solution A, B, C is given and their pH value is given 8. Solution A has the pH value 8, solution B has the pH value 3 and solution C has the pH value 7. What are the questions? Questions are, which solution will give only hydronium ion as only positive ion? Which solution will turn red litmus to blue? Which solution has the pH as distilled water, has the same pH as the distilled water? And what is the change in color of the solution A when methyl orange added dropwise in it? Children, what is the answer of this question? Take a pause, write the answer, and after that, please check it with me. Which solution will give you only hydronium ion as only positive ion? See, hydronium ion is the only positive ion. In that case, if it is acidic, which solution is acidic here? So solution B, because it is pH value is, if the pH value is less than 7, then it is acidic. So which solution is acidic in nature? So bit I as answer is B. Solution B. The solution which turns red litmus to blue. Red litmus to blue means red litmus to blue means definitely red to blue, basic. Which solution is basic in nature? This means the solution A is basic in nature. Which solution has same pH as a distilled water? Distilled water is a neutral solution. So distilled water has the same pH. Suppose it is third number. So distilled solution C has the neutral solution because its pH is 7. So answer is C. What is the change in color of the solution A when methyl orange is added dropwise in it? Solution A is basic in nature. When we add the methyl orange to a basic solution, it turns yellow in color. Children, you will expect this type of question in your exam. So please go through your video, watch it, try to understand the concept, and if you like my video, please don't forget to like, comment, share and subscribe to my channel. Thank you. Thank you for watching.